Hello guys, welcome to today's tutorial. Today we'll be taking on algebra. Get your writing materials ready with your calculators. We'll be right back. Algebra is a broad and fundamental area of mathematics which covers expressions, equations, inequalities, quadratic equations, etc. Now let's look at what are expressions. Expressions are algebraic expressions involves variables, constants, and mathematical operations. Example, when we have just this is a variable, your x is a variable, while your 3 is your constant, and your mathematical operation is your plus, addition, subtraction, division, and the rest of them. So now, for expressions are just normal write-out of your mathematical um, variables like 2x plus 3, x squared minus 4, 3 brackets, x minus 2. These are just examples of expression. Now, when we talk about equations, equations states that two expressions are equal to another number or equal to 0. Okay? Now, equations talks about your two expressions. Now we have the first expression is 2x plus 3. The second expression is 5. All right. Now, equations talks about bringing two expressions together. 2x plus 3 equals to 5. Now, equations help us to find the value of our variables. Now, this another example is x squared minus 4 equals to 0 and x plus 2 equals to 7. These are examples of equations. If we talk about inequalities, inequalities compare expressions using the terms greater than, less than, greater than or equal to, or less than or equal to. These four terms are the four major terms used in inequality. We have the greater than, we have the less than, we have the less than or equal to, and we have the greater than or equal to. These expressions are what we use to represent inequality. So whenever you see an expression that bears the symbols, this which is greater than, this which is less than, this which is less than or equals to, and this which is greater than or equal to. All right, these four symbols represent your inequality. So whenever you see symbols like this, your mind should just strike directly to inequalities. All right, examples we have 2x plus 3 is greater than 5, and we also have x squared minus 4 is less than or equal to 0, and x squared plus 2 is less than 7. Now for this, let me quickly make a difference, state the difference between this. Now this greater than simply means that your value of x is higher than the stated number. Let's say, for example, x is greater than 7. It simply means that x ranges from 8, 9, 10, and above. All right. When we say x is less than 6, it means that x ranges from 5, 4, 3, 2 downwards. Now, when we talk about less than or equal to, when we say x is less than or equal to 5, it means that x could be 5, 4, 3, 2, 1, and so on. Now, if we talk about x is greater than or equal to 6, it means that x could be 6, 7, 8, 9, 10, and so on. So you should know the difference between your less than or equal to and less than alone. All right, now looking at quadratic equations. Quadratic equations involve a squared variable, and it can be written in form of our ax squared plus minus bx plus minus c equal to 0. Okay, now once we will see our x squared in this form, we should know that we are working on quadratic equations. Once we see our x squared in this form, we should know that it's a quadratic equation. Now, this a is a constant, where a, b, c are constants. Now, the first example we have there is x squared plus 4x plus 4 equals to 0. Now, in this situation, our a is equal to 1. Our b is equals to 4. And our c is equals to 4. All right. Now, a is the coefficient of your x squared. B is the coefficient of your x, and C is your constant in the given equation. Now, for the second example we have there, we have it as 2x squared minus 3x minus 1 equals to 0. Now, in this situation, our A equals to 2, our B equals to, the coefficient of x is minus 3, and our constant c is minus 1. All right, so whenever you see your x being squared in your expressions, giving you equals to 0, that means you are working on quadratic equations. Now, talking about patterns. Patterns involve sequence of numbers or objects that follow a specific rule. Sequence or objects that follow a specific rule. Now, there are two major types of patterns or sequence we have. We have the arithmetic sequence and the geometric sequence. When I talk about the arithmetic sequence, now, arithmetic sequence or arithmetic progression Okay, our arithmetic sequence deals majorly with addition and subtraction. Okay, now we have what we call the common difference. We have what we call the common difference in arithmetic progression. And in order to find our arithmetic progression or sequence, we'll do our second term minus our first term, or the third term minus the second term, or the fourth term minus the third term. Now, for the example we have there, we have our sequence as 2, 4, 6, 8. Now, if we want to find the arithmetic and the common difference for this sequence, we either do, this is our first term, we either do 4 minus 2, which will give us 2, or we do 6 minus 4, which will still give us 2, or we do 8 minus 4, which will still give us 2. So the common difference for this sequence is 2. Now, our first term, which is A, is our first number in the sequence. Our first term, which is A, is our first number in the sequence. Then, followed by the first term, is our second term, third term, fourth term, and so on. Now, the general formula for arithmetic sequence is Tn equals to A plus bracket open n minus 1d. Now, where your A is your first term, your n is the number of sequence which you are looking for, and d is your common difference. Now, let's look at an example. Let's say we want to find the seventh term of this sequence. If we want to find the seventh term of this sequence, we know that our A is 2, and our D is 2. All right, so Tn, which is going to be T7, which is the seventh term we are looking for, will become 2 plus 7 minus 1 times 2. This will give us 2 plus 7 minus 1, 6 times 2. So 6 times 2 will give us 12. 12 plus 2 will give us 14. So the seventh term of this sequence will be 14. And that is how you get your number of terms in your sequence. Now, looking at geometric progression. Geometric progression, on the other hand, deals with division and multiplication. Deals with division and multiplication. Now, if we look at the example we have there, we have our sequence as 2, 4, 8, 16. Now, in geometric progression, we have what we call the common ratio. Now, your common ratio can simply be found by T2 over T1, or T3 over T2, or T4 over T3, and so on. Now, your T2 in this case is your 4, and your T1 is your 2. So our common ratio here will become 4 divided by 2 will be 2. If we look at our third term and second term, if we do 8 over 4, we are still having 2. If we do fourth term and third term, 16 over 8, we are still having 2. So our common ratio for this term, for this sequence, is 2. And in order to find our geometric ratios, we have the formula as Tn equals to AR raised power n minus 1. Okay, now where our A is also our first term, our R is our common ratio. Now, N is the number of terms which you're looking for. Now, for example, let's look for the 10th term of this sequence. So if you are looking for the 10th term of this sequence, this is going to be T10 equals to our A is 2 times our R is 2 raised power 10 minus 1. So this will give us T10 equals to 2 times 2 raised power 9. So 2 raised power 9 will give us 2 times 512. So T10 is going to give us 512 times 2, which will give us 1024. So our 10th term for this sequence will be 1024. We have the linear inequality and we have the quadratic inequality. Now, the linear inequality is always, is always direct, while the quadratic inequality deals with your quadratic equations. You having to solve out a quadratic equation as an inequality. Now, for the linear inequality, we have ax plus b less than or greater than or less than or equals to or greater than our constant c. While for the quadratic, you can see we have a quadratic equation on one side tending towards or leading towards 0 on the other side. Now, there are certain rules to understand why solving inequality. 1, you should always add, subtract, multiply, or divide both sides by same value. Now, let's say, for example, we have 2x plus 3 is greater than 6. Okay? Now, if we want to, okay, let's say it's greater than 7. Now, if we want to solve this, what do? We first of all, since we have an addition sign here, we'll do what? Move it over towards this side and it will become a subtraction. So you need to watch out for which sign you are having, whether it is addition, subtraction, multiplication, or division. In that manner, when you know the opposite of each sign, now for addition, signs and their opposites. So if we have addition, the opposite will be subtraction. If we have multiplication, the opposite will be division, and vice versa. So bearing in mind of this, if we have square root, the opposite will be, if we have square root, the opposite will be squared. So bearing in mind of this, okay, bearing in mind of this, you should be able to know whenever you're moving your signs over an equality sign, it changes. Okay, so for positive now, crossing over equality becomes negative. So this will become 2x greater than 7 minus 3. Why is it now minus? Because our positive have crossed over to turn to minus. So 2x greater than 4. So x, now for us to make x stand alone, since 2 is multiplying x, we look for the opposite of multiplication is division. So we divide both sides by the coefficient of x, which is 2. So this becomes 2x over 2, 4 over 2. So our x will give us 2. So x will be greater than 2. Now, in this case, our sign is not changing. Now, let's look at a case that will require our sign to change. So if we have 2x plus 4 greater than minus 3. Okay, no, let's use all right, 2x plus 4 is greater than 5x plus 3. Okay, now in this case, we have to do what? Collect like terms. If we collect like terms, we are going to have 2x minus 5x greater than 3 minus 4. Okay, so at those points, this will give us minus 3x is greater than minus 1. Okay, so now we divide both sides by minus 3x. If we divide both sides by minus 3x, this will give us minus 3x over minus 3 minus 1 over minus 3. So our minus will cancel out, leaving us with x is greater than 1 over 3. Okay, now for this, our sign didn't also change. So let me look for a question that will change our sign. So that, okay, let me just explain it. For your sign to change, okay, for your sign to change, let's say we have a negative x. Let's say we have a negative x greater than or less than, greater than our positive 4. Okay, now in this situation, when we have a negative x in this situation, what do? We have to eliminate this minus by introducing a minus to this other side. So in introducing this minus, our sign would change. So by the time we introduce a minus, this x becomes x is less than minus 4. Why? Because we are eliminating this minus from this side over to this side, so our signs will change. So always be careful when you have a negative in your inequality to ensure that your signs are placed appropriately. All right. Question. The next step to also observe is to also isolate your variables, which we've seen in this case, how we isolated our variables to find out the value of our variables. Example 1, we have 2x plus 3 greater than 5. Now, if we are to solve 2x plus 3 greater than 5, now, following our first rule we have there, it says that we should do what? Watch our signs. Our sign here is positive addition. So if we move our addition over to the other side by collecting like terms, we have a constant and a constant. This will become 2x greater than 5 minus 3. Okay? That is what we simply did here, was subtract 3 from both sides. Okay? Now we'll have this as 2x greater than 2. Now at this point, we have isolated our variable. At this point, we have isolated our variable. Now, our variable has a constant attached to it. What do? We have to divide both sides by the constant of our variable, since it's multiplying. So if you say 2x divided by 2 is greater than 2 over 2. So x is greater than 1. That is our solution. Now, for example 2, we have it as x squared minus 4 is less than or equal to 0. Now, this is a square sign. Remember, I explained to you the opposite of the signs we have. So when we have a squared, we should bear in mind that we will do a square root of that to get our answer. Now, first we have a negative. Now, opposite of negative is addition. So in order to eliminate this negative, we have to add 4 to both sides. So this becomes x squared minus 4 plus 4 less than or equals to 0 plus 4. So this will cancel out, leaving us with x squared less than or equals to 4. Now, the next thing is your isolated variable. What is the sign with it? Does it have any constant, any coefficient? No, the coefficient here is 1. So this is x squared. So for us to find x, we'll take square root of both sides. So if we take square root of both sides, this becomes x squared, finding the square root, less than or equals to square root of 4. So this will cancel this, leaving us with x less than or equal to square root of 4 will give us 2. So this is the answer to our variable. Right, graphing our inequalities. For the linear inequalities, we use a number line. Now, what do we refer to as a number line? A number line is a line that indicates the positive and negative aspects of our numbers, with 0 being our center of origin. Now, this is 0, towards this way is positive, towards this way is negative. So from here we have 1, 2, 3, 4, all positive. Here we have -1, -2, -3, -4. So for example, where we have x is greater than 2. For us to represent this on our number line, the value of x will be greater than 2. Now notice that I didn't shade it. Okay? Once it is not shaded, it simply means that it is greater than or less than. But for example, if I have our 0, 1, 2, 3, -1, -2, -3, where x is less than or equals to -2. Okay, let's say x is less than or equals to 2. From 2 here, now this represents that x is less than or equal to 2, while this represents that x is greater than 2. For us to represent equal to or greater than in our inequality, it has to be shaded. While for the greater than alone or less than alone, it won't be shaded. Now, what do we mean by a parabola? Quadratic inequalities comes in this form. Okay, where we have the minimum or our maximum. Okay, quadratic inequality is an inequality that involves a quadratic expression, and it is written in the form below: ax squared plus bx plus c greater than 0. Now, when we sum it out and plot our graph, all right, solving quadratic inequalities, we have to first of all follow the following steps. We'll write the inequality in standard form, which is in this form, where you have your ax squared plus bx plus our c is greater than or less than or equal to whichever one, 0. Okay, now you factor out your factors of your quadratic expression if possible. You know, we have about 3 ways majorly of factoring out our factors. We have the factorization method, we have the completing the square method, and we have the quadratic formula. Now the fourth part is your graph method. Okay, now this way, when you factor out your factors, now the roots of your quadratic equations are set to be equal to 0. Okay, now let's say we have x plus 5 equals to, let's say our roots of equation are x plus 5 and x plus 2 or x minus 2. Now, if these are our 2 roots of equation, we'll equate them to 0. This will become x plus 5 equal to 0 and x minus 2 equal to 0. So therefore, our x here will give us a minus 5 and our x here will give us a minus 2. Alright, now having the value, our x here will give us a minus 5 and our x here will give us a plus 2. Now, having found the roots of your x, the next thing you will do is to use this root to divide your line into intervals. Now, you use this rule, your factors, to divide your lines into intervals, where you can do it as divided by 2. This will become 0, which is the point of origin, 2, 4, minus 6, minus 8, minus 10, and so on. Same thing for the positive side for the x and y. Now, at the end of the day, you test its intervals to determine which satisfies this equation. So for x equals to minus 5, you test to see if it satisfies you at x minus 5 or x plus 2. So whichever one satisfies the equation will be your graph for your equation. Whether it will be the minimum, when it is negative, it becomes your minimum, and when it is positive, it becomes your maximum. All right, let's look at x squared minus 4x minus 5 is greater than 0. Now, if we are to factor this, let's factorize this. This will give us minus 5x squared. What are our factors of 5 that will give us 4? We have 5 and 1. So this will be 5x and x. Now, since this is negative and this is negative, our 5 will become negative. So this will become x squared minus 5x plus x minus 5. Grouping these two together, we have x minus 5 plus 1, x minus 5. Okay, now having this, we have common terms in our bracket. This becomes x plus 1, x minus 5. So if we should equate this to 0, this becomes x plus 1 equals to 0. So therefore, x equals to minus 1 and x minus 5 equals to 0. So therefore, x equals to plus 5. Okay, now the roots of our equation will become minus 1 and plus 5. Now, if we look at the intervals, we have our intervals ranging from minus 1 to positive 5. Okay, now our infinity here is brought in at both extremes if, should in case, our what do we call it, our roots do not fall in place or is greater than this. That's why we have our infinities at both ends. But the major intervals we are looking at is minus 1 and 5. All right, now for the solution of this, our solution will become our minus 1 and will be the solution of our equation. Okay, now the graphical representation of this will be y equals to x squared minus 4x minus 5. Now, for us to find the value of y in order to plot this, we'll now substitute when x equals to minus 1 and when x equals to 5. So for us to find the value of y, what we're going to do here is y equals to minus 1 squared minus 4 bracket minus 1 minus 5. This will give us y equals to 1 plus 4 minus 5. So y equals to 0 when x is 1. So when x is minus 1, okay, let me put it this way. When x is minus 1, y is 0. And when x is 5, what will be our value of y? Y equals to x, okay, this will be 5 squared minus 4 bracket 5 minus 5. So this will become y equals to 25 minus 20 minus 5. Okay, so our y equals to what? 0, 2. So when x is 0, when x is minus 1, y is 0. When x is 5, y is 0. So let's look at what our plot will be like. So if we have it this way, so when x is, and we have minus 1, minus 2, minus 3, 1, 2, 3, 4, 5. All right, now when x is 1, our y is 0. And when x is 5, our y is 0. So this forms the two extremes of our quadratic graph. So now to find whether it's going to be up or down, we are going to, what's the interval between them? Okay, let's look at using 2. So when x is 2, okay, after minus 1, we have 0. So when x is 0, this becomes y equals to 0 squared minus 0 plus, minus 5. Okay, so 0 minus 0, so y will give us y equals to minus 5. Now, since x is 0, y is minus 5, that means our minus 5 will come down this way. Okay, so when x is 1, we calculate it that way. When x is 1, 2. So at the end of the day, you find out that your graph is coming in this form. Okay, now this gives you the minimum value for your graph, which helps you in knowing whether it's opening upward or is opening downward. Okay, so the parabola opens upward and the solution intervals are where the graph meets on both the x-axis and on both the x-axis. So just like we've said, you can use your graph to find the roots of your equation where your parabola, where your curve cuts the x-axis. So at this point and at this point will give you the roots of your equation from your graph work. All right, looking at quadratic equations. Quadratic equation is a polynomial equation of degree 2. When we talk about second degree, it means x raised to power 2 or y raised to power 2 or any alphabet raised to power 2, which means the highest power of that variable is 2. Okay? And it's in the general form of our ax squared plus bx plus c, where a, b, c are constants, okay, that are greater than 0. Now, x is your variable. Now, in solving quadratic equations, it is necessary to follow the following. There are several steps or methods to solve quadratic equations. Now, first of all, we'll look at if the quadratic expressions can be factored into two numbers or into two products. Now, if we are able to factor the quadratic expressions, then it becomes easier to solve. Now, if we cannot factor this, find the factors of our quadratic equations, we can use our quadratic formula to solve it. And our quadratic formula simply states that minus bx equals to minus b plus minus root b squared minus 4ac all over 2a. Now, where a, b, and c are your constants from your quadratic equations. Now, we can also use completing the square method in solving our quadratic equations. Like I said earlier, there are 4 major ways of solving your quadratic equations, which are the factorization method, quadratic formula method, completing the square method, and we just finished looking at the graphical method. So these are the 4 major ways of solving quadratic equations. Now, example 1. Let's look at x squared plus 5x plus 6 equals to 0. Now, if we do this, this becomes 6x squared. Now, can we find the factors of 6 that will give us 5? Now, what are the factors of 6? We have 1 and 6. We have 2 and 3. All right. Now, let's see if 1 and 6 satisfies what we are looking for. Now, if we have 1 and 6, now we do, since this is positive, that means both of them can be positive. 1 times 6 will give us 6, which is a tick, correct? But 1 plus 6 will not give us 5. This will give us 7. Now, if we look at the negative aspect of it, minus times minus will give us a positive 6, which is correct. But minus plus minus 1 minus 6 will give us a minus 7, which isn't what we are looking for. We are looking for a positive 5. So this won't fly. Minus 1 minus 6 won't be our factors. Now let's look at the next group of factors. We have 2 and 3. Now 2 times 3 will give us 6, which is a tick. Now 2 plus 3 will give us a positive 5, which is also a tick. So the factors we will use here will be 2 and 3. So we have 2x and 3x. Okay, now in place of this 5, we'll replace it with 2x and 3x. So this becomes x squared plus 2x plus 3x plus 6 equals 0. Now grouping these two together, this becomes what is common, x bracket x plus 2. What is common here? 3 plus 3 bracket x plus 2. So we can say our two factors out to become x plus 3 and x plus 2 will become our two factors. All are equal to 0. So x plus 3 equals to 0. So therefore our value of x will become minus 3 and x plus 2 equals to 0. So therefore our value of x will become minus 2. All right, that is for factorization. All right, our next example looks at x squared plus 4x plus 4 equals to 0. Now we have x squared plus 4x plus 4 equal to 0. Okay, now if we factorize this, this will give us 4x squared. Now the factors of 4 that will give us 4 will be 2 and 2. So this will become 2x, 2x. Now replacing this here, this becomes x squared plus 2x plus 2x plus 4. Okay, so x, which is common, x plus 2, and plus 2, which is common, x plus 2. So at this point, we're having x plus 2 equals to 0. Now, x plus 2 equals to 0, so therefore x equals to minus 2. And x plus 2 equals to 0, so therefore x equals to minus 2. So from here, we can see that our value of x will be minus 2. Now let's look at application of our quadratic formula. In a situation where we have our question as x squared plus 2x plus 1 equals to 0. Okay, now if we cannot factor out this, because this will give us x squared. Okay, now since this cannot be factored out, we'll use our quadratic formula that says x equals to minus b plus minus root b squared minus 4ac all over 2a. Now in this situation, our a equals to 1 because our coefficient of x squared is 1. Our b equals to plus 2 and our c equals to plus 1. Okay, now applying this into this formula, our x is going to become minus 2 plus minus root 2 squared minus 4 times a is 1 times c is 1 all over 2 times a, which is 1. Okay, now at this point, let's expand. We're having x equals to minus 2 plus minus root 4 minus 4, okay, all over 2. Okay, root 4 minus 4 will give us 0. So our x equals to minus 2 plus minus root 0. And we know that root 0 will give us 0. So our x equals to, okay, all over 2, sorry. So our x will equals to minus 2 all over 2, which will give us x equals to minus 1. So the value of x will be minus 1. All right, let's look at some more examples. We have x squared plus 7x plus 12 equals to 0. Okay, if we factor out this, we can decide to factor out since if it's factorable, or we use our almighty formula, which is our quadratic formula, to solve it. But let's see, is it factorable? If it's factorable, let's do 12x squared. What are the factors of 12 that will give us 7? Now let's look at factors of 12. We have 1 and 12. No, it won't give us 7. We have 2 and 6. It won't give us 7. We have 3 and 4. This is most likely to give us 7. So our factors here will become 3 and 4. Now the next thing to consider, is it positive or negative? Since it's positive, both will remain positive because 3 plus 4 will give us a positive 7 and 3 times 4 will give us a positive 12. So now, replacing this for 7, we have x squared plus 3x plus 4x plus 12 equals to 0. Now grouping these two together, we have x, which is common. All right, bringing it out, we have x plus 3. And we have 4, which is common. We have x plus 3 equal to 0. So since these two terms are common, this becomes x plus 4, x plus 3 equal to 0. X plus 4 equals to 0. So therefore, x equals to minus 4. And x plus 3 equals to 0. So therefore, x equals to minus 3. All right, looking at 2x, x squared plus 5x minus 3 equal to 0. Now, our a at this point, we are going to apply our quadratic formula. So let's find our a is 2, b is plus 5, and c is minus 3. Okay, now our quadratic formula states that x equals to minus b plus minus root b squared minus 4ac all over 2a. Now, imputing this, substituting these values into this formula, we have minus b will give us minus 5 plus minus root 5 squared minus 4 times a is 2 and c is minus 3 all over 2 times a is 2. Okay? So our x is going to become minus 5 plus minus root 5 squared is 25 minus 4 times 2, 8, 8 times 3, 24, minus times minus plus. So this will give us plus 24 all over 4. So this will become x equals to minus 5 plus minus root 25 plus 4. 24 will give us 49 all over 4. Okay, now x equals to minus 5 plus root 49 is 7 plus minus 7 all over 4. Now we can separate our signs to become x equals to minus 5 plus 7 over 4 or minus 5 minus 7 over 4. All right. Minus 5 plus 7 will give us 2 over 4 or minus 12 over 4. So this will give us the values of x will become half or minus 3. This will give us the values of our x for this quadratic equation. All right, looking at some more examples on quadratic inequalities, it says solve x squared plus 2x minus 3 greater than 0. So we have x squared plus 2x minus 3 greater than 0. Now, just same way as we solve our quadratic equations, we'll first of all factor out what our factors will be for this quadratic equation. So let's look at factoring out. We have 3 minus 3x squared. Now, what are the factors of 3? We know that the factors of 3 are just 3 and 1. So this becomes 3x and 1x. All right. Now, since this is negative, one of them has to be negative. Bear in mind that this is positive. So if one of them has to be negative, that means the smaller one will be negative, because minus 3 times minus 1 will give you minus 3. 3 minus 1 will give you a positive 2. All right. So having done that, we now come back to our x squared plus 3x minus 1x minus 3. Okay, grouping them together, what's common here is x bracket x plus 3. What's common here is 1 bracket x plus 3. Okay, so this becomes x minus 1 and x plus 3. Now back to our sign, greater than 0. So x minus 1 is greater than 0. So therefore, x is what? Greater than x is greater than 1, and x plus 3 is greater than 0. So therefore, x is greater than minus 3. Okay, now Having done that, we know that our critical points are these graphs. Our points on this graph will become 1 and -3. So with this, we've come to the end of today's tutorial. If there will be any questions, comments, please put them in the comment section below. And don't forget to subscribe, like, and click on your notification buttons to get updated with our latest videos.